Now we're going to look at the properties of the tangent graph. So let's go ahead and graph the basic tangent function. And the first thing that you notice about the tangent, probably, that's different from the sine and cosine, is that it's not all one connected piece. So it is it's definitely not continuous. It has these breaks in it. Where do these breaks occur? Well, at pi over 2, we have a break. At 3 pi over 2, 5 pi over 2. And notice those are exactly the places where we would be dividing by 0. So, remember the tangent of an angle in the unit circle picture, okay, that we can find the tangent of the angle as the y value over the x value. The x value is the cosine. So notice anytime that the cosine graph hits the x-axis, okay, and where does that happen? That happens at pi over 2, 3 pi over 2, 5 pi over 2, odd multiples of pi over 2, including the negative ones. Any of those places, the tangent function is undefined, and so we have vertical asymptotes. Now it is continuous everywhere it's defined, so in between these asymptotes, we're a nice connected piece here. But it breaks at those vertical asymptotes, and again, they're going to happen anytime the cosine is equal to 0. Of course, the cosine is equal to 0 exactly when the sine is equal to 1 or negative 1. And notice that the sine is equal to 0 when cosine is 1 or negative 1. And when the sine, the red one, is equal to 0, so is the green one, the tangent. So notice the tangent and the sine will both touch each other on the x-axis, and that's the only places those two graphs cross, and that will happen exactly when they're both 0 for y, and that happens at multiples of pi. Okay, and of course if you notice all these places, you're going to see the unit circle. It's either going to be pointing straight to the right there, or straight to the left. And notice when the graph is pointing straight to the right, these graphs are kind of going along the same direction there, whereas here, when the unit circle is pointing straight to the left, then we have the tangents increasing and the sine is decreasing. In fact, when we look at the tangent, it's actually increasing on every piece. Of course, it's not increasing necessarily from over here to down here, but as you cross over from one piece to the next, but as long as you stay within one piece, they're the same. It is increasing. Now also notice that if you go from negative pi over 2 to pi over 2, for example, so look at where that's doing on the unit circle, from straight down to straight up on the unit circle, then you actually trace through the whole cycle once, or you trace through the whole cycle once from 0 to pi. So this one actually has a period of pi. If we can see that on the graph here on the right, is if we shift this graph to the right by pi, you get the same graph. So let's kind of summarize some of the important things about tangent. Okay, so we have y equals tangent of x. We have the domain is all reals except for the places where it has asymptotes and where it's undefined. And so those would happen at odd multiples of pi over 2. So you could either write that here, you could write that as 2n minus 1, or you could write that as 2n plus 1. It could be written either way right there. That could be a plus or a minus, because when you take 2 times an integer, you get an even number, and then you either add 1 or subtract 1, either one, you get an odd number. So now we have an odd number times pi over 2, and we get all odd numbers by letting n be any even number, or any integer, excuse me. So 2n is even, 2n plus 1 is odd, times pi over 2. So that gives you all of the things. There where it's undefined, so that's what it's not. It is anything else, all reals except for that. That's what the domain is. And in asymptotes, the asymptotes are x equals the same values. Where does it hit the x-axis, the x-intercepts? Well, let's see. It's here. It's at 0, pi, 2 pi, 3 pi, 4 pi, negative 2 pi. That's all of the multiples of pi. So that's just n pi. And, of course, y is 0. It does cross the y-axis at 0, 0. So 0, 0 is both an x and y intercept. And it turns out, like sine and cosine, that the inflection points and the x-intercepts are exactly the same. And so in this case, notice when it crosses the x-axis, to the left of that point is concave down, and to the right of that point is concave up. So we have an inflection point there as well as being a root. Okay, and then it happens again here at pi. Just to the left of that is concave down, and just to the right is concave up. Its period is pi. Now the period of sine, cosine, secant, and cosecant are all 2 pi, but tangent and cotangent, the period is pi. And we've seen this before because they actually repeat themselves, not just a full circle rotation, which is a little more obvious, but they also repeat in a half circle pattern as well. Notice that when you look at the graph, there is no maximum or minimum. Even on one piece, it goes all the way from minus infinity to infinity for the range. It is increasing on each connected piece. And the identities from the symmetry, if we look at the tangent of the opposite of x, that's the opposite of tangent of x. This means this is an odd function, and we get origin symmetry. So that means that if I rotate this 180 degrees around the origin, we get a graph that looks the same. And so this is going to rotate all the way around and you get the same looking graph. So tangent of minus x is the opposite of tangent of x. Okay, on the unit circle that says if you take the in the units, well, let me see if I can show you that. So I take a point here, for example, and then go the opposite direction by the same amount, we're going to get the opposite y's here on the tangent. What that means over here on the unit circle, look at it, if we rotate here a certain amount, and then rotate in the negative direction by the same amount, they have the same x but opposite y's, that's going to give them the opposite tangents. Okay, what about tangents of supplementary angles? So in the unit circle, so we have one here, and then we have pi minus that value over here. So let's say we have, let's just take, for example, pi over 4, and we do pi minus pi over 4, it'd be 3 pi over 4 here. Those are supplementary angles. And where does that, what does that get us? Well, that gets us opposite tangents. They have the same reference triangles, but their tangents are opposite over here in the unit circle picture when you're talking about first quadrant and second quadrant terminal sides, or in general, anytime that you're talking about pi minus x and x for the two angles, you're going to get opposite tangents. So tangent of pi minus x is the opposite tangent of x. And if you do pi plus x, that pi is actually the period. So when you do pi plus x, we're shifting this graph to the right by pi, and we get exactly this, or actually to the left by pi. But if you shift it to the left or right by pi, you get the same graph. And so tangent of pi plus x is the same as tangent of x. And so that summarizes some of the properties of the tangent function.